Hello everyone, Rob here. I've had a request to do some tutorials on the very good free antenna simulation software called Hfss. It's done by Hfss, and he has very kindly enabled everyone to use this software completely free, and it is, in my opinion, as good as anything you'll get out there, and in fact it's probably better than many, but it will at least give you an opportunity to try your own antenna simulations. So let's begin. Now, in this particular tutorial we're going to look at the user interface and what the buttons do, and demystify the first layer of complexity when you look at almost any program, which is what do all the buttons do. So let's install it. I've removed it, so hopefully there are no little bits left over from a previous installation. We'll see in just a moment. It's very good software. I think any effort you put into investigating it will be very well rewarded. Okay, now it puts up a few different tools. The one you want is the Hfss, the little tower with the radiating circles. Okay, and here we go. Now it comes up here and you look at it and you say, well, what do I do next? Well, in this particular tutorial we're just going to have a look at the user interface. The idea of this series of tutorials is that we'll go from the beginning right through to constructing your own antenna virtually and optimizing it, if necessary figuring out which versions of matching networks we want to put in to reduce the SWR. If we want to make an antenna with gain, we show how to use the optimization tool to improve the gain characteristics or whatever other parameter you want. We'll also be looking at all the editors, and they all have their own little pluses and minuses. It's a very versatile program. So let's get straight into it. The most important thing is this menu bar. Now, if we have a look, they're all pretty straightforward. When we press the open file, it gives us access to a large number of already pre-configured antennas. If you look at them, they all have a .nec suffix or extension. That is indicating it's an antenna definition file. Okay, at the moment we don't want to actually use any extra antennas, so we'll just, because we want to build our own, so we'll just leave that blank. This is the save button, and you can save a definition of an output file. There's nothing available because we haven't defined an antenna. Now this is just defining, okay, we're back at the main window. This one will give us the 3D geometry window, which is this particular thing here, and this enables us to, for example, have a look at the antenna. Now there is an example antenna put here as when you first start the program, and so you can see it looks like a dipole and it's probably in free space. Then we have a 3D view. If you have a look here with the 3D view, it gives us a view similar to the geometry view, except that by actually clicking certain of these buttons you can actually see the gain in a graphical way. It's very colourful and really helps to visualize the sort of characteristics an antenna has. There's nothing, these buttons are greyed out at the moment because we haven't actually done the calculation yet, and I don't want to do that until after we've gone through all the buttons. Okay, now the next thing, and this is very useful, this is the editor button. Now if you press this button it'll take you into an editor. Now this editor here, you look at it and you go, you know, what are all these, you know, cryptic symbols? Well, I wouldn't worry too much about that at the moment. This is the notepad editor. Now if you're a sort of person who likes to do things just by typing them in quickly, and you're very easygoing or very comfortable with these particular symbols, you already know how the NEC card system works, by all means use this. But in fact you can choose one of quite a number of editors, and if you click on the settings, and you'll see that you've got 1, 2, 3, 4 different types of editors. We'll be going through all those, and each one has a particular characteristic which may endear it to you. For example, this is a geometry editor where you can basically graphically build your antenna. This is the basic NEC editor, which is beloved by those people who wish to use the card system. We'll go through all those a bit later. All these are greyed out. Now the reason they're greyed out is because we haven't actually calculated the characteristics of this particular example antenna yet, but we'll come to that. Now this is the calculate button. Now this button you will use all the time. So it will allow you to calculate the far field, near field, frequency sweep, and all sorts of other things. So just keep that in mind. Let's now have a look at some of these grey buttons by pressing the calculate button. Keep in mind we have this example antenna. Now the example antenna, let's define an editor which is a little bit easier to see. Let's use the geometry editor. So you go to the settings, tick which particular editor you wish, then whenever you press this button here, the editor button, it will bring up that particular editor, and there it is. Now we'll go in more detail, but basically if you have a look at the grounding structure, this is free space. That's what I just wanted to show you. Okay, now let's press the button. So this is a dipole in free space. The frequency is 300 megahertz. We select the far field pattern. That's what we're most interested in. Okay, now we have a number of screens. We have this screen here, which is what we always have, the geometry screen. This is the field pattern. Now by pressing the space bar, you can see there's not much difference, but that's because it's in free space. But we have some characteristics. We'll make this a lot more exciting later on. And you'll also notice that now we have this button here. This is the near or far field, so it just selects this particular one, this particular screen. We can also have a look at the Smith chart. So for those people who like to use Smith charts, there you go. You can actually have one there, and it's produced for this particular antenna configuration. The next one here is the actual output from the NEC, which is the actual engine which produces the characteristics of the antenna. So maybe some people would be interested in that. It's not my sort of bedtime reading, but some people may be. If you do want it, it's there for you. Okay, we have here matching networks. If you press that button, it will give you all different types of networks which you can select, and for the frequency and also for the source and the load, which the load is automatically calculated from the antenna. You can then select the type of network you want and the matching, and it will give you the values of capacitance and inductance to establish a close match to 50 ohm line in this case, although you can change this to 450 if you wish, or whatever. The choice is yours. And this says view the user manual. There is no user manual here, so there you go. And the help file, there you go. And all these buttons here are in the help file, and it's very worthwhile to have a bit of a browse through the help file. You can see just from looking through it all the things you can do. But we'll be taking the easy approach and just going through it step by step. Okay, well, that's part one, which is just a basic familiarity. Now, that's the buttons. Let's just go through some of these top menu settings here. You can open a file, save a file. You can input an NEC file. That is the antenna definition file. And this is the output file which is used by NEC to produce the graphical pictorial representation of the antenna. I wouldn't worry too much about this. What you'll be doing most of the time anyway is just inputting a file. Now then we have the settings. These are the editors, 1, 2, 3, 4. This is auto segmentation, where I haven't described segmentation yet, but the way that NEC works is it breaks up a conductor into a number of smaller lengths. It then calculates for each of one of those lengths what its contribution will be to the radio frequency field. So the number of little breaks that you chop up the conductor into is called the number of segments, and this will just do it automatically. Now this is stepped radius correction, which basically is if you have a stepped antenna, for example, made out of tubes which vary in diameter, they're one inside the other, telescoped, this will correct for that. The input power, the characteristic impedance, predefined frequencies. Symbols are simply a way of saying, instead of saying the length of this antenna is 10, you just say height equals 10. That symbol would be height. So it's just a way of attaching a name to a value. It makes it a lot more clearer, and it also is necessary for use of the optimizer, but we'll go into that in a later tutorial. Circular or polar, this is the representation that you want. For those people who know what polar coordinates are, these are particular characteristics of the radiation pattern, which I don't think most people would worry too much about. The length that you'll be using to define your antenna, quite important, whether you want to use meters or wavelengths or feet or inches. You just select which one you want. We'll leave it at meters just at this moment. The radius, unit of measurement, millimeters or inches or AWG. Again, fairly self-explanatory. The method of measurement used for how thick the conductors are. The NEC engine you want to use, NEC can do up to 11,000 segments. It's just phenomenal and wonderful. But the more segments that you have, of course, the longer it's going to take to calculate. There's not many ways out of that. However, if you do want to have an extremely complicated antenna system, or very accurate, you can do it. Memory usage, this is a little bit esoteric. I just leave everything where it is. Now, optimizer and the evaluation type of system, this is very useful, and this describes the sorts of steps you want it to take. Do you want it to be linear, or do you want it to be logarithmic, or whatever type of system you want it to step when it actually changes its values to try and get the optimum setting. Again, just leave it at default. We're not going to be describing VOA cap and that sort of thing, so I'm not going to worry too much about that. If you're interested in it, by all means do it, but it again can support it, but we won't be doing that. We'll be just evaluating antennas. Other settings, again, just leave it where it is. You've got things like use a linear scale or logarithmic scale. Again, we won't worry, just leave it at where it is. Folders, these are just for various, for Windows. Again, just leave them where they are. Now calculate NEC output data, so you can just press F7. If you want to do matching, F10, start the optimizer, F12. We'll be going through those things in more detail later on. Which window you want to have a look at: the main window, which is the window we're looking at, the geometry window, which is this one, the pattern window, which is not there at the moment because I minimized it, but that's where the beam pattern is, the 3D viewer, and the Smith chart, all fairly explanatory. Polar notation or load info, this is again, we'll be doing this a little bit later on, but basically they're just different ways of representing the view. And again, just ways of running various programs. We'll only be using a couple of those, we won't be using any of these. And the help file. Okay, well, I think it's probably enough for one session, so I hope that's given you a little bit of a look through the user interface. Oh, something I almost forgot, and that's very important. We'll have a look and see what all these things are. Okay, the file name, that's the name of the output file. The frequency, of course, very important. The wavelength, that's obviously bears relationship to the frequency. That's automatically calculated. The voltage at the feed point, the impedance at the feed point, the parallel form of the impedance. If you know that you can have a series or a parallel form of the impedance, it gives you both. The SWR relative to 50 ohms, the efficiency of the antenna, the radiation efficiency, in other words how well it actually radiates, not just how well the currents actually zip along the antenna, the amount of decibels, this is actually the radiation efficiency, but it's in decibels. RDF, oh no, sorry, I'm going to have to go over that again a little bit. The current in the antenna, the series component, the parallel component, this is the equivalent antenna inductance or capacitance. In other words, you're looking into it, you see a combination of a resistor and a reactance. So what actually is the value of that? And of course, if you have the series component of this, if you put a capacitor in, it will cancel it out, and therefore you can have a purely resistive load. The input power assumed, the loss in the structure, and the radiated power. Okay, the environment, this is just a comment, which is free space. And then the comment which you can actually put in there. The number of segments, the pattern lines, the evaluation steps. Well, we only did one because we haven't used the optimizer yet, and the calculation time. Theta and phi. That's something I'm not going to cover because, frankly, I never use it, and I doubt many people would. But if you do, by all means, have a look at it. Okay, I'll leave it there for today, and we'll do using the editors and generating your first antenna in the next tutorial. Anyway, I hope that was of some interest to you. Thanks for watching, and 73s.